Okay, this is why we made you learn how to factor. We're going to solve equations by factoring. So these are mostly going to be quadratic equations, which could be solved with the quadratic formula, but if they factor, solving by factoring is much more efficient. First of all, important distinction here. Polynomial expressions are expressions. There's no equal sign, there's nothing to be solved. We can evaluate them, but we can't solve them. So everything we did in Module 2 is a polynomial expression. What we're going to be seeing today are polynomial equations. So equations have equal signs. And in particular, we're going to be trying to set our polynomial equations equal to 0, because that's going to be important to us. So equations can be solved, while expressions can only be simplified or factored, but not solved. And to do the solving, we need something called the zero factor property, which says if you're multiplying two things and get 0, then either one or the other has to be equal to 0. This is true if there's more than two factors, but only works if the factored form is equal to 0. So if we have, say, x times x plus 2 equal to 0, each of these factors can be set equal to 0, and this is going to be how we solve our equations by factoring. Okay, so these would be a couple of typical problems. We've got a quadratic equation set equal to 0. We're going to factor the left-hand side. So this one should factor pretty easily. The leading coefficient is 1, so we should be able to factor just to an x times x. And then the 6 is either going to factor to 1 and 6 or 2 and 3. And I'm thinking 2 and 3 will do the trick, as long as they're both subtract. Because negative 2 times negative 3 multiplies to a positive 6, whereas the outside and inside, negative 3x and negative 2x, add up to the negative 5x. Now, again, this is an equation, so we need to bring down the equal and the 0. And what our zero factor law says is we can now set each of these factors equal to 0. And we've got two simple linear equations to solve. This gives us our two solutions, x equals 2 and x equals 3. If we'd used the quadratic formula, we would have gotten the same result, but it would have taken us a lot longer to get there. So the next one will also factor. So this one's going to take a little more work with the 3x squared here. If we take the a times c, 3 times the negative 2 is negative 6. Here, I'm factoring by grouping, by the way. And then the negative 6 could factor to 1 and 6. Negative 1 oh, how about negative 1 positive 6? That adds up to 5. So I can expand this to 3x squared, subtract 1x, plus 6x, subtract 2 equals 0. Don't forget the other side of your equation. Factoring by grouping, I can factor an x out of the first pair, leaving behind 3x, subtract 1, and factor a 2 out of the second pair, again leave behind a 3x, subtract 1. This then factors to 3x, subtract 1, times x plus 2 equals 0. If you prefer to factor that one by the guess and check, that's fine. Your choice, however you like to factor. But once we have it factored, we're now going this extra step. We're setting each of the two factors equal to 0, and then we can solve each of these for x. So I'm getting x equals 1/3 and x equals negative 2. Okay, this one's a little trickier. It already looks factored because we have x times 5x subtract 7, but the critical thing to notice is that it's equal to negative 2. The zero factor property only works if we're set equal to 0. So need to set equal to 0. So we can get in there, clean things up, get it into a usual quadratic equation. So distributing the x, 5x squared subtract 7x equals negative 2. 5x squared subtract 7x plus 2 equals to 0. And now we can factor the left-hand side because the right-hand side is set equal to 0. Let's see. Let me try this one with guess and check. Let's see how I do. 5x squared's got to be 5x and x. And 2 is either going to be 1 and 2 or 2 and 1. I'm thinking 2 and 1 and a couple of subtractions will work. That'll give me 5x squared, negative 1x, and negative 5x and negative 2x is negative 7x, and negative 2 times negative 2 is positive 2. So once it's factored, set each factor equal to 0, solve each factor, x is 2/5, and x equals 1. Okay, so general procedure, write the equation in standard form with one side equal to 0. So that's standard form, ax squared plus bx plus c equals 0. Factor the polynomial completely. Set each factor containing a variable equal to 0. So if we manage to factor out a greatest common factor that's just a constant, we don't need to worry about that constant. Solve the resulting equations, and then check each solution in the original equation. A couple more. Why don't I let you try this one first? I'll pause, and then we'll compare. So do we get the same result? First brought the 72 over to set the polynomial equal to 0. I got it to factor to y plus 9, y subtract 8. Set each of those individual factors to 0 and got my solutions. Y equals negative 9 and y equals 8. And then I did a check. Negative 9 squared plus negative 9 is 81 subtract 9, which is 72. And then 8 squared plus 8 is 64 plus 8, which also gives me 72. Okay, there's a trick to this next one. It's kind of ugly looking with that fraction. But remember, we're now working with equations. And we can pretty much do what we like to equations as long as we're doing the same thing to both sides of the equation. So to start this one off, I'm going to multiply both sides by 2, doubling all of the coefficients. And don't forget to get the other side of the equation. Then I've got it set equal to 6, and I've got an equation without any fractions. Now before I can solve, before I do my factoring, I'll want to set the equation equal to 0. Let's see. Looks like there's quite a few combinations. You get 4 and negative 6, so I think I'll do the factoring by grouping here. A times c is negative 24. Looking at my factors of negative 24. Let's see, 1 and 24, 2 and 12, 3, maybe 3 and 8. How about a positive 3 and negative 8? Adds up to negative 5. So maybe negative 3 and positive 8 adds up to positive 5, but multiplies to negative 24. So using that to expand out my quadratic equation here, I'll have 4x squared, subtract 3x, plus 8x, subtract 6 equals 0. Factoring by grouping, I can take an x out of the first pair, 4x subtract 3. Take a 2 out of the second pair, also gives me 4x subtract 3. So I've got my common factor. Factor that out. 4x subtract 3, x plus 2 equals 0. Now in our previous sections, this is where we would have stopped, but now we're going to actually solve our equation. So I need a little more room on my page. Okay. Set each factor equal to 0. 4x subtract 3 equals 0. X plus 2 equals 0. 4x equals 3. X equals 3/4 is my first solution. And x equals negative 2 is my second solution. A couple more to try here. These get a little more interesting because we have some third powers here, x cubes. But again, we want to first get everything set equal to 0 before we factor, and then we'll see how many factors we have. We may have some more than 2 solutions on these. So moving everything to the left side, x is common, so I can factor out the x. Now what's left inside is a quadratic. This one factors pretty easily. I think an x subtract 3 and an x plus 2 should do the trick. So now I've got three factors to set equal to 0. I set the x equal to 0, the x subtract 3 equal to 0, and the x plus 2 equal to 0. And I've got two solutions, 0, 3, and negative 2. I'll let you try the next one while I pause a minute. So how'd we do? Get all the terms onto one side again, and we've got 4 terms, so this is an excellent one to use factoring by grouping. Grouping the first pair, I had an x squared common, leaving behind x plus 7. And for the second pair, I was able to factor out a negative 4, also giving me an x plus 7. So negative 4 times a positive 7 is a negative 28. So be careful with the sign. Once we have that common x plus 7, we can factor it out. And then notice what's left. X squared subtract 4 is the difference of squares. So this can also be factored to x plus 2, x subtract 2. Now I have 3 factors. Set each of the 3 factors equal to 0 and solve, and I get my 3 solutions. We'll continue this next section on another tape.